Hello, so today we are going to do this problem, which is part of Leetcode daily challenge. Find the town judge. So this problem, it says that we have a town and we have n people labeled from 1 to n. Okay, and there is a rumor basically that there is that one of these people is secretly the town judge, right? So sort of we have a 1 to n people, and one of them may be the town judge, and we are trying to figure out what's the label of the town judge if they are there. If they are not, we want to return -1. So that's what we are trying to figure out here. And so what are the properties of the town judge that we can try to find them by? So the first one is that town judge trusts nobody, and the context here is that we get a list of trust that represents basically a list of A and B values, and if you have A, B, then that means A trusts B. So it's this direction of the trust, right? And so the town judge trusts nobody, right? So that means if it exists in the list, it should never be in the first position. And then the other part is that everybody, except of course the town judge itself, should trust the town judge, right? So basically that tells you that n-1 people should trust the town judge because the nth one is the town judge itself, right? If the town judge is in the list. And that's pretty much it. Now, if we take a look at this, here it tells us that there are 2 people, right? And 1 trusts 2, okay? So that tells you that 2 trusts no one, so this property is verified, and tells us that everybody else, which is just 1, trusts the town judge. 1 trusts 2, so that means the town judge is labeled 2, okay? If we take a look at the second one, 1 trusts 3, 2 trusts 3, but 3 trusts no one, right? 3 never shows up in the first position. But everyone else, which are just 1 and 2, trusts 3. And so 3 is the town judge. Now, if you take a look at the last one, 1 trusts 3, 2 trusts 3, and 3 trusts 1. So the labels we have are 1, 2, 3, and each of them is in the first position here. Each of them trusts someone else. So the judge is neither of them, okay? So we return -1. So that's pretty much the problem. We have up to 1000, so we can do an O(n) squared solution, but we probably won't need an O(n) squared. So let's see how we can do it. So let's just pretty much just do as the problem tells us. So what we want to figure out is who trusts who, right? So here, let's just keep the list. So trust of X would be basically the list of those that A trusts, like X trusts, okay? And then let's have trusted by, okay? Collection where we keep track of those that are trusted by something. So here, let's just have it a collection of lists. So default dict list. And then here, let's just have this be the same thing, but let's have this one be trusted by X, basically is the list of those trusted by X, right? Why do we need those 2, right? Or I'm trying to solve it in the simplest way possible, right? So let's say we have the second example here, which is a little bit more interesting. Okay, so this is the second example. So what do we want to figure out? Well, what are the properties of the town judge, right? So the properties are that they are trusted by, so basically for I to be town judge, right? We need I to be trusted by everyone except I, right? Except the town judge itself. Plus we need I to not trust anyone, okay? Then we can tell it's a judge. So how can we translate this into something in terms of these, right? So we can say trusted by everyone. That means that trusted by, the length of the trusted by for I needs to be equal to n-1, right? Because it's everyone else. So the entire list of people is n. One of them is the judge. So the remaining ones are n-1. So that means that I needs to be trusted by n minus 1 people. That's the first property. The second property is that we need I to not trust anyone, right? And so that means we have the trusts list here that we record, which tells us how many, which tells us the list of the people that I trusts. And so this here needs to be equal to 0, right? Okay. But you can tell here we actually just need the count. We don't need the values themselves. So let's change this then to an int. So, and this becomes how many, and then this becomes how many are trusted by X, okay? And so now we just go through the list of trusts first so that we can fill these two arrays, right? And so this in trust. So basically this tells us that A trusts B, okay? So that means immediately that A, the number of those that A trusts is just increased by 1. What about trusted by for B? So this tells us also that A trusts B, which basically tells us that B is trusted by A, which tells us that the number of those trusted by B, the number of those that are trusted by, so A trusts B, which tells us that B is trusted by A. So the number of those that trust B just increase it by 1, right? Okay, I hope that was clear. So this is those that trusts A, and this is those that are those that B is trusted by, if that makes sense, right? I know it's a little bit tricky to imagine, but it's those that are trusted by B. So this basically, and so now we can just apply this. So in range of n, and of course n is this one here, and we want to just check if basically we changed it from length, so now we just changed it to count, so now we just need to check this, right? So if trusted by I is equal to n minus 1, so basically those that trust I are equal to n minus 1. Actually, maybe I should rename it. So trust me, let's call them, and let's call this I trust. I hope this wording may make it clear. And so we need, actually I don't think it makes it clear. Let's skip the old one. So those that trusted by I, so those that trust the judge, n minus 1, they need to be n minus 1. And those that I, the judge, trust should be 0. Okay, so if that's the case, then we want to return I. But if we go and we don't find it, we want to return minus 1. Okay, so let's just go through this. Okay, let's see why it's failing. So we go, because the labels are from 1 to n, so we need this to be 1 to n. And that looks good. Let's submit. And that passes test cases. Now, just one modification we can do actually. Let's change this a little bit, right? So let's just try to do it with one dictionary. So let's have a count here, because also the wording here I realize may be a little bit hard to understand completely. So let's just have a count, or let's call it balance. And so what will happen is that, well, let's do something where we balance of trust, we increase it by 1. So for example, if we have AB, so balance of trust increased by 1 for B when A trusts it. So when A trusts B, and then the balance of trust decreases by 1 if you trust someone, right? For A, because A trusts B, and because A trusts B, right? So if you basically, what we'll do here is that if you trust someone, balance decreases by 1. And if someone trusts you, balance increases by 1. How would this be helpful? Well, for the judge, what we need is, we need basically n minus 1 trusted by n minus 1 and trusts 0, right? So this tells us that the balance for the judge should be equal to n minus 1. And only for the judge, right? Other people should at least trust someone else. And so it will decrease for the other people. And so if we keep track of the balance, then we can just check the one with the balance equal to n minus 1, right? And so that's exactly what we'll do here. So let's just have balance is +1 and balance of this one is -1. So actually this is the reverse. So the balance of B, because if you trust someone, your balance decreases by 1. And so A trusts B, so A's balance needs to decrease by 1. If someone trusts you, your balance increases by 1, right? And B, there is someone that trusts B, which is A, so its balance increases by 1. And now instead of looking for this, we just look for something where the balance of I is equal to n minus 1, and we return I. Okay, let's run this. So let's just call this the same name. Submit. And that passes, right? You could make this a little bit slightly fancier. So return if any of these has balance of I. You could do it like this, and then otherwise do -1. Let's see if this works. Yeah, so that's pretty much it actually for this problem. Now, in terms of time complexity, trusts is probably going to be order of n length, and so the first loop is O of n. Here the loop is O of n as well, right? In terms of space, we are using this extra space here. But these two are time, right? So overall, it's O of n time and O of n space, right? So O of n time, and we are using O of n space as well because of the balance dictionary here. Yeah, so that's pretty much it for today's problem. Please like and subscribe and consider supporting me on Patreon, and see you on the next one. Bye.